Hey, so today we're going to be talking about optimization. This is just an introduction, so it's not going to be fully into solving problems, but we are going to introduce what optimization is. So let's start with an example. You've probably seen these types of questions before, but let's try to view it through a different lens. So God, that's fine. Find two numbers whose sum is equal to 100 and whose product is the maximum. Let's not write out is the maximum. Let's just write maximum there. Is the maximum. So again, you've probably seen those types of questions before, but bear with me. So in order to see that the sum is maximum, well, let's say that the two numbers are x and y. So sum is equal to 100. The product is the maximum, so x times y, let's say p, a big P. So now we just kind of have to replace and see where it works out, right? So if we have x plus y is equal to 100, then x is equal to 100 minus y. Then we can plug that in to this bottom equation. 100 minus y times y is equal to p. And then that means 100y minus y squared is equal to p. Well, this is a kind of weird equation to solve because now you have two variables that you have to really solve for, right? Sure, but if we take the derivative of p, this is where it gets a little bit different. If you take the derivative of p, then you get 100 minus 2y. Then you can kind of replace and see. So that would also mean negative 2. If we factor out negative 2, then we get y minus 50. So then a 0 for y would be when y equals 50. Then we can go back to this. X plus y equals 100. So what plus 50 is equal to 100? Well, 50. So your two numbers are 50 and 50. So there are some rules for solving optimization problems. I'm going to erase all of this. Actually, let's do it this way. And I'll write them out. So, some guidelines, not necessarily rules, but guidelines. Identify all given quantities. Identify all given quantities. Actually, what I'll do is I'll write all of this out and then come back when I'm done. Whew, we're back. Okay, so these rules are kind of like a convoluted way to say just solve the problem and use calculus, use derivatives, but if they help, please write them down, make sure you internalize them. They do help some people if you want to think of it step by step. So step 1 is identify all given quantities to be determined. Make a sketch if you can. So that's when we did like the XY thing. Obviously, we didn't need a sketch for that because that was just two numbers, but sometimes you might need a sketch if it's like a word problem. Write primary equation for maximized or minimized quantity. So we had our x plus y is equal to 100 and x times y is the maximum, or p. Reduce the equation to one variable using substitution. So when we plugged it into the second equation and solved for one of the variables. That was what that was. Determine feasible domain, values that make sense for the problem. So we didn't technically do this, but I'm sure that you had in your head that the numbers had to have been less than 100 if they had to add up to 100. You can, you can probably logic it out and figure out like what the maximum it could have been was. And we actually solved for that, would be 50 for this specific problem. But as long as you know that, like, if you get an absolutely crazy answer and you're like, wait, this doesn't make sense, listen to your gut, make sure that you did the problem right. And step 5, determine maximum or minimum with calculus technique. So that was just when we had the derivative and solved for y, and then plugged that back in to solve for x. So those are all the steps. I'm not going to do another problem because this is an introduction, but I will have another video for solving optimization problems where we can kind of put this to the test. So I'll see you then.